Hey, 81's a pretty quick one. And so in 81, they say when an opinion poll calls a residential telephone at random, there's only 20% chance the call reaches a live person. You watch the random digit dialing machine make 15 calls. Let X equal the number of calls that reach a live person. So the first thing that you need to ask yourself, especially because this comes in section 6.3, is what type of random variable is it? Is it the two that we looked at, binomial or geometric? And so remember bins. Okay, so bins, the B stands for binomial. And so that means success or failure. And so a success is reaching a live person, and failure is not. Independence is met because one random phone call dialed doesn't impact the next one or the one that came before it. So that's independence. N stands for the number of trials, 15 calls, and S stands for same probability, and the probability is 15%. Okay, so what you need to realize when you do 81, the most important piece of it is that this is a binomial random variable. And since it is a binomial random variable, if you look at my document that I have here, these two formulas, the first one on the left, mu sub x equals np, applies to the mean. And the one on the right, sigma sub x equals square root np times 1 minus p is the standard deviation. And so I bet you could get it from there. If you like, I can continue to solve that. But in the 81 part A, the N would represent the 15, and the P, where did it go? I'm looking, 20%. So in the first one, we're going to go, let's see if it works. There we go. And so we're going to go 15 times 0.2, and that's equal to 15 times 0.2 is equal to 3. And then remember, the key thing is the interpretation. And so here's the interpretation. If we watch the machine make many sets of 15 calls, we would expect, remember the word expect is connected to the mean, about 3 calls to reach a live person on average. Okay, and the second piece of this is the standard deviation. Okay, so just taking a look at that. So square root of n again was 15, and then times p, which is 0.2, and then times, whoops, that's an e. I meant 0.2, and then times 1 minus p, so 1 minus 0.2 is 0.8, and so you get, when you do that, 15 times 0.2 times 0.8, 1.55, and here's the interpretation. If we watch the machine make many sets of 15 calls, we would expect the number of calls that reach a live person to typically vary by about 1.55 from the mean of 3. Typically vary. Make sure when you're interpreting on the test, standard deviation, use a phrase like typically vary or typically off or something like that. That's kind of a key word that the grader looks for to see that you understand standard deviation. Hope that helps. And again, thank you for asking questions. I really hope that people emailing me solutions becomes infectious and everyone starts doing it. It's really fun for me to do. So I really enjoy and appreciate that you're doing this. Hope it helps. Let me know if I did the wrong question or if something did make sense. Thank you.